This is problem 8D on the practice problems for test number 1. A chemist needs 10 liters of a 40% alcohol solution. How many liters each of a 65% alcohol solution and a 25% alcohol solution must she combine to get the desired solution? So this problem is one similar to stuff we've done in class, and we've used a table to help us organize all the information in this problem. So if you haven't already made the table, go ahead and pause the video here and then make the table and come back. I think making the table is a big part of the problem. So I've written my table. It's probably not going to be exactly the same as yours, but it should have the relevant information the same as this one. So we've got a column for the amount of solution. Whoops. Try that again. We've got a column for the amount of solution. That's here. That's the amount of liquid in each of these different pieces. Then we've got another column for the percent alcohol. That's going to be the easiest one to fill in. And then finally, how much alcohol do we have from each of the pieces and how much do we want in the total? So we should have a bottom row for the total. And now we're going to start filling some things in. We've got two different kinds of mixtures here. So I'm going to call these low and high, low concentration and high concentration. And so before I start filling in the table with variables, I need to define my variables. So we're going to let L equal the amount or the number of liters of the low solution, the 25% solution. And then I'll put here in parentheses that I'm using L for low. And then same kind of idea for the high. I use H. Number of liters of the high solution, the 65% solution. H for high. I think it's better to use letters that give you some information about what the variable represents as opposed to using X and Y every time. So now I'm ready to start filling in my table. So the amount of solution, I'm looking in this top left box here. So how much solution do we have for the low? Well, it's a variable. We just called it L. So I'm putting an L there. Continuing down this column, amount of solution for the high concentration. That's easy. We called it H. Now the total might be tempting to put L plus H, which is correct. But we actually have more information given to us in this problem. We know that the chemist needs a total of 10 liters. So I'm putting a number right there. It's 10. Next column, percent of alcohol. This is the easiest one to fill in. What percent do we have for low? It's 25. But if I just put 25 there, I've actually made a mistake. Remember, we always want to convert our percentages into decimals. So 25% is really 0.25. What percent do we have for the high? That's 65%, but again, write a decimal. What percent for the total? Please, please, please don't decide to add up the two numbers up above. 0.90 is not right. In this case, we're looking for a 40% alcohol solution, so 0.40 goes right there. The last column is pretty straightforward once you've done the pattern of make this table, because the last column is just the product of the first two columns. If we take the amount of solution, the actual amount of liquid, multiply it by the percent of that liquid that's alcohol, we're going to get the actual amount of alcohol, the number of liters of alcohol. So we're just going to multiply straight across the top row, 0.25 times L, I'll write it that way. Middle row, 0.65 times H. Bottom row, 0.40 times 10, which is equal to 4. 4 liters of alcohol is desired. Okay, now we need some equations. So first equation is going to come from this first column. I know the amount of solution I had was L liters for the low concentration, H liters for the high concentration, but altogether 10 liters total. And the other equation is going to come from the last column. The amount of alcohol I had from the low stuff was 0.25 L. That's how many liters of alcohol we had coming from the low concentration. I additionally had some alcohol coming from the high concentration. 0.65H is the number of liters of alcohol coming from the high. But I know how many liters I wanted total. I wanted 4 liters of alcohol total to make up my 40% solution. So finally here in black, we've got our 2 equations, and now it's pure algebra. Don't have to worry about the chemistry or any other stuff at this point. I don't like having all these percentages here, all these decimals, I should say. So I'm going to multiply everything in this equation by 100. Remember, multiplying by 100 moves the decimal point 2 places to the right, which would give me a 25L right there, which is more friendly for me. So we get 25L plus 65H. Don't forget to multiply the right-hand side by 100 as well. So I've got that. And then my other equation is L plus H equals 10. So you're welcome to solve this system of equations by either using substitution or elimination. I'll use substitution, but really they're probably about the same amount of work. I'm going to try to make the L's cancel when I do my, I don't know if I said I was going to use substitution, but I'm going to use elimination. You can try substitution. I'm going to eliminate the L's to try to make those L's go away. I need to get the coefficients to be the same number but opposite. So I've got 25L in the top. I really want negative 25L in the bottom. So I'm going to put a negative 25 there. But I can't just go around multiplying that single L term by negative 25. I need to multiply the whole equation by negative 25. So distributing that negative through gives me negative 25L minus 25H equals negative 250. I'm going to copy that blue equation right down here below. And when I add these equations up, something nice happens. If you add the equations, the L's cancel right there. That's why we built it. That's how we built it, was to make those L's go away. So we just add the H's. There are 40 of them. Negative 250 plus 400 is positive 150. So H is equal to 150 over 40. You can write that as a reduced fraction. Ultimately, I'm going to want a decimal here. You can type it in or figure it out based on the fraction. But we get 3.75 liters of the high solution. And then to figure out what L is equal to, we're going to want to go back to one of our original equations. So we had the 2 of them right up here in black at the top. The simpler looking one is the one on the left. Let's use that one. It says L plus H is 10. So I'll write it down here. L plus H is 10. But we just figured out that H is really 3.75. And subtract that 3.75 from both sides to get that L is equal to 6.25. So that means that our final answer is 3.75 liters of high, but now I'm going to put the percentage here. So the high was 65%. Maybe we should say 3.5 liters of 65%, and then 6.25 liters of the low, which was 25%.